Now, not everything in the world has a frequency of 1, so I've heard. Here's our Maclaurin polynomial for cosine x, but what if we had a cosine at some other frequency? What would you hope the answer would be? And then maybe we can check that. So take a sec to write out what you would hope the Maclaurin polynomial for cosine 3x would be without doing a whole bunch of derivative work. So I would hope that it would be anywhere you see an x here, replace it with 3x. Does that seem to make sense? So 1 minus 1 over 2 factorial 3x squared plus 1 over 4 factorial 3x to the 4th minus 1 over 6 factorial 3x to the 6th. Does that seem plausible? Do you think this needs fixing? I think it needs a big fixing. We said anywhere you see an x, replace it with 3x, but then what we should be doing is anywhere you see like x squared, you should be squaring whatever that thing is. That thing is 3x. So we really have to make sure we have parentheses like this. Okay, so that's a big important thing. Whatever you give this, it squares that. If you give it 3x, it should square the 3x, not just the x. So that's our hope. Let's say that's our hope. Now we should actually go check it by doing all the derivative calculations. So maybe pause the video and come back when you're done. So we'll do order 0, 1, 2, 3, 4, 5, 6. Derivative formula, cosine 3x, and then what's f prime for cosine 3x? Derivative of cosine is negative sine 3x, and then we have to do a chain rule times 3x prime, which gives us negative sine 3x times 3. And then second derivative of negative sine is negative cosine 3x times 3, copying the 3 times the derivative of the inside again. So we get negative cosine 3x times 3 squared. So can you see what pattern we're going to end up with here? The negative cosine derivative is going to give us a positive sine 3x, and then the 3 squared there plus with another 3 from the chain rule is going to give us times 3 cubed, and then cosine 3x. We have 3 factors of 3 now. We're going to have 4, and then negative sine 3x times 3 to the 5th, and negative cosine 3x times 3 to the 6th. Phew. And what x value should we use? So the derivative value at x equals what? In some sense I didn't say like x equals 0 or x equals negative pi over 2 or something, but we did say Maclaurin, and Maclaurin means at x equals 0. So we're going to use a 0 there. What's the value of cosine 3 times 0? That is just 1. And then sine of 3 times 0 is 0. Cosine is 1 with a negative, so we get negative 3 squared. Get a 0 there. And then here, positive 1 times 3 to the 4th, 0 there, and then negative 1 times 3 to the 6th. So then what's our polynomial terms? This 1 gives us a 1, and then a 0. We'll just skip the 0. And then plus negative 3 squared. I was about to write x minus c, but I don't need to because this is a Maclaurin series, so I don't need to subtract c because c is 0. So x squared over 2 factorial, skip the 0, plus 1 times 3 to the 4th, x to the 4th over 4 factorial, plus minus 1, 3 to the 6th, x to the 6th over 6 factorial. So is that ending up to be equal to this? Well, it doesn't quite look the same because like here we have a 3 to the 6th, x to the 6th. Here we have a 3x to the 6th. Oh wait, that is the same. You can just kind of distribute the 6 as an exponential, as a power. So yep, it all works out.